Hey, physics kids, this is Mr. Galoya coming at you. How are y'all doing today? I hope you're doing fine. Listen, I'm putting together the unit on Unit 10, our unit on forces, and we're kind of now done really kind of with the first chunk of physics, and that first chunk of physics really then is called kinematics, and it's kind of the ideas of Galileo, and we're kind of moving now from Galileo to another important scientist. His name is Isaac Newton, and maybe you probably have heard of him. Isaac Newton was kind of a generation after Galileo. Galileo lives in Italy, and Isaac Newton then comes a little bit later historically than Galileo, and Isaac Newton lives in England. He was very well he was very well acquainted with a lot of Galileo's ideas, and in fact he used a lot of Galileo's work to formulate his ideas. Now, I don't know if you know a lot about Newton, but he was really an incredible sort of kind of person. This kind of picture here just gives you kind of a brief kind of, in a picture, kind of a brief summary of some of his research. I don't know if you kind of know a little bit about Newton's life, but he grew up kind of on a farm and in England, and he was a pretty precocious child, and he was hold on, I was getting a phone call there. He was pretty precocious as a child, did a lot of tinkering and building some things, etc. But he had gone off to Cambridge to college, and he was about 18 or so, just a little bit older than you guys. And around that time, the plague, bubonic plague, kind of went through Europe and England. And they kind of did some things like what's happening now too. They in this case they closed down the university and they sent all the students home for a few years. And Galileo was around 18 or 19, and he goes back to the farm. And the years of around 18, when he's 18, 19, 20, he does some incredible work. And he works on the light spectrum with the prism. That's Roy G. Biv. He basically comes up with his 3 laws of motion. He co-invents calculus. He deduces really the effects of gravity and how to explain, the motions in our solar system. He invents a type of a telescope called a Newtonian reflector. This was kind of the telescope I grew up with. One of his Newtonian reflectors that uses kind of a series of mirrors. So within that period of 2 or 3 years, he just does some incredible work. So this unit really is all about what forces are, and a force is a push or a pull. And it's a pretty easy definition, really. Now you might really want to know, well, what's the difference between Galileo and Newton? Well, Galileo really explains how things move, the types of motion that we have, and that's what we've been studying, right? CV, CA. But Newton really gets into the why we have CB and the why we have accelerations. And basically the idea is this, that we can look at the forces on objects, and if those forces are what we call balanced, we might say that the object's in equilibrium in terms of its forces. If the forces are balanced, that means we're going to have CV. So, for example, I'm sitting here at my computer desk. the earth is pulling me down. That's a force. We call that weight. And the floor itself is supporting my weight. That upward force is a support force. Those two forces are balanced. They're numerically equal. Consequently, right now I'm doing CV, really, as I talk to you. I'm not really moving. Okay, my velocity is 0, which is an example of CV. I could be in maybe my car traveling with the cruise control on. Then all my forward forces, my forces behind me, my forward or back forces are all numerically equal. The up forces and the down forces are equal. So when we have balanced forces, we have CV. Well, we can also have forces, though, that are unbalanced. And when we have unbalanced forces, then we have an acceleration. So maybe in terms of my car, I put the foot on the gas to accelerate. Maybe I'm passing a vehicle. And so I've got stronger or more numerical force that's propelling me forward. So basically, that's the idea, really, of what Newton did. He took Galileo's ideas, but he really kind of came up with why do we have these types of motion. And in this unit, we'll be kind of exploring the idea of forces and Newton's three laws of motion. That it can explain really almost everything. So Newton's ideas can really almost explain all the motion we have. Now there are some exceptions when we start talking about extreme forces of gravity or extreme velocity. Then we have to kind of get into Einstein's ideas. But for most of all motion throughout the universe, we can explain those motions with the ideas of Galileo and Newton. Okay, what are the basic ideas of the unit? Well, we have Newton's three laws of motion. We have 1, 2, and 3. You'll explore a little bit about what that means. What is a force? Common forces and their symbols. Forces can be divided up into what are called contact forces or field forces. Contact forces, then objects have to touch for that force to be expressed. Field forces, though, can act throughout a distance. So gravity is what's called a field force. So the sun is exerting a gravitational pull on the earth, but the earth and the sun aren't touching. Gravity's a field force. We have the units of force. In our country, we typically use pounds. So when I get on a scale, I might weigh 150 pounds. The metric system, though, we have newtons, and that was named after Isaac Newton. Well, we have different instruments to measure forces. And if I step on a bathroom scale, that's an instrument that measures my weight. We've got then the idea of balanced and unbalanced forces. One common area that's a little bit confusing for students is mass and weight. And you'll learn a little bit about both of these, mass and weight. We've got units for mass, instruments for mass. We've got units for weight. Weight is a force. For example, the earth pulls down a mass. The earth pulls down my mass and creates a weight. We have an equation then that couples these two together. Weight equals mg. This is actually an example of Newton's second law. Mass is what's called location independent. So my mass is the same regardless of really where I am in the universe. I'm so many kilograms of mass. But my weight is based on the acceleration due to gravity. See, there's that little g. So weight is location dependent. So on the moon, for example, I'm going to weigh less than I am here on the earth because the acceleration due to gravity is much less. Now you're going to find out that this unit is more conceptual in nature. A lot of these questions can be answered conceptually. There is some numerical sorts of things in the unit, Newton's second law, F equals ma, or weight equals mg, but definitely less kind of equations than what we've seen so far. Now, let me kind of tell you really where we're heading in the next few units. So, now that we're kind of dealing with forces, we're going to kind of couple some of the concepts of Newton and Galileo together. So we'll be talking about circular motion, and we'll be talking about what's called work and energy. So like work in terms of physics is the coupling of force and distance. Impulse, momentum, the coupling of force and time, and mass and velocity. So that's kind of where we're heading. It's kind of an amalgamation or a coupling of the ideas and the concepts of both of these scientists. Okay, well, so in this unit, there'll be some websites to look at. I don't think there's too many videos to see. I think most of the push I'm doing is through websites, and then there'll be some, as always, some assignments, and then the assessment. Sounds good? We'll talk to you later, kids. Bye.